Yeah, hi. So today I'm going to talk about solid principles in Java. Basically, it can be useful for any other OOPS language as well. But I want to I want to demonstrate them in Java. So let us take a look at what solid principles are and how they are important. And let us look into the examples in Java, like what is how beneficial it is to you know to include a principle, and what happens if we do not adhere to this principle. So let's look into the first letter of the solid principles, which is S. Again, I mean, the solid principle itself states that the each letter in that particular word defines a principle. S for single responsibility, O for open close principle, L for Liskov substitution, I for interface segregation, and for D dependency inversion. So here, let us talk about the first one, which is single responsibility principle. So by definition, a single responsibility principle states that a class should have only one reason to change. And again, if we talk about it more clearly, then a class should do one thing and do it well, right? So if you have, few things to do, if you have, I mean, one responsibility to do, then you will have to be, more accountable for it, and you don't need to, look at other things. You can concentrate on this one. I mean, in the real world. In the similar fashion, if a class is having only one thing or one responsibility, so it will be only changed when that particular responsibility, or when this there is a change in the particular job that it does, then only we'll have to change that particular class. Otherwise, the otherwise it's quite simple. It's more maintainable. It's more easier to test. It's again scalable. So let us talk about the benefits of it after we look into a single responsibility example. So I have taken some examples for each of the principle here. Let us look at the solid single responsibility principle, and that too, let us look into a bad example, which is non-compliant one. Okay. So here you can see there is a class called user account, which is having some sort of variables for user, and there is another method called a login, and there is another method or functionality for encryption of the password, and the other one for sending the email. So if you see here, the user account class, I mean, it's fine if it holds, I mean, as the name says, user account, it's fine that, if it holds these two things, and that's fine because it is username and password, which are related to the user account. But if you see here, the login functionality seems different. And this is an additional responsibility for this user account. And the same is the case with encryption, and as well as send welcome no, email. So if take a close look at this one, you'll understand the problems. It has four responsibilities. One is, handling user data, authentication, encryption, as well as email. So it has four reasons to change, and which is a clear violation of the single responsibility principle. When we say single responsibility principle, we should think about, one reason to change. I mean, one responsibility and thereby one reason to change. That's what is all about single responsibility principle. And let us go back to the sheet again. So you have to ask yourself once again. So when you are when you're dealing with a single responsibility principle, you have to, I mean, you want to follow this principle. I mean, it is really needed and necessary. Then you have to ask this question straightforward, which is, does this class change for more than one reason? If it is yes, then you have to split it up. Again, if you, let's say here there are four reasons, and I'll keep one thing here and I'll move the rest three into a different class. That also does not work. Again, that becomes a three responsibilities and three reasons to change. You have to move each one of it individually to a different class. So let us look into a good example or a compliant one where you see there are four different classes holding user details, username, password, or whatever. If something comes up here, there is a modification or there is a change in user logic, then that comes here. So without altering the logic of auth service, or without worrying about some email or whatever. And auth service, it does take care of login functionality or login related logic, and email service, it worries about the notification part. And the same is the case with encryption. It only takes care of the encryption. And whenever there is a change in encryption, you only have to touch this one, and it has only one responsibility. So yeah, this is what single responsibility principle is. Now let's look into the other principle. The other principle is open closed principle. Okay, so by definition, software entity should be open for extension but closed for modification. Just remember the name and open for extension and closed for modification, which means you should be able to freely add a new behavior, but you should not really try to touch the existing code. You should not do that. I mean, basically you should be reluctant to, but rather you create interfaces or abstraction class, I mean abstract class, and try to extend them in such a way, by using polymorphism or interfaces, you should be able to achieve that. But if you have already created a Java class, and the moment you feel that it is there needs to be some change in the logic, or then you find out that something needs to be added, then you should not touch it. You should initially you should create a class or anything in such a way that you should not alter it too much. I mean, you should provide a scope to add new behavior without really modifying the existing thing. Let's see how that can be achieved by using this uh, you know example in real Java. So let me go back to open closed principle. Here, let us look at again the bad example first. This is a notification service we are talking about. And here there is a method named send method, which accepts, what kind of notification it is, and then followed by the message. If you look here, there are some if and else conditions stating, if it is an email, you do the, you do the computation of, whatever sending the email. And if it is an SMS, you take care of the logic here of, how you need to send an SMS. Let's say on a later date, if you want to, send a notification via WhatsApp, then again you have to modify this class, which is again violating the closed for modification principle, right? You are open for extension, you are open for addition, but you are not open for modification, right? So when you're trying to modify it, you are breaking the principle. So let's see how we can fix this using a compliant solution. So here in the compliant solution, what we need to think about is whenever we are trying to, do something, instead of doing a concrete implementation, we should go with interfaces. We'll try to, in all this principle, you look into the interfaces, or you look into the, a subclass and superclass, those kind of things. So yeah. So let us look into the good example of open closed, in which we have something called notifier, right? So which only declares a method which is void send method, and whatever the message you want to send, you do it. And now I can have an email notifier which has which overrides the send method with its logic of sending an email. I have an SMS notifier which has again overridden the send method of the notifier. I mean, these two classes are implementing the notifier interface. So here we are sending the message with its own logic. Let's say if I want to now is the case. So let's say if I want to add a new notifier, which is a modification, right? So I don't need to, go and modify notifier, or go and modify email notifier, or whatever in the SMS notifier. But rather I can simply create a new class, Java class. We can say what's up notifier, and it's yeah WhatsApp notifier, and I can implement which implements notifier, and then we'll have to implement the methods, right? Send method. So the logic to send a notification via WhatsApp. So this is how you can do. You are not touching, unlike the non-compliant one where you need to add an if and else condition, but here you can create a new class. And let's look into the usage of it, right? So there is a notification service on top of all these notifiers, email notifier, SMS notifier, or WhatsApp notifier, which has another method which states notify, and it accepts a notifier as well as the message that we want to notify about. So it does again do notifier dot send message, right? I mean, notifier is having a message method send, and it accepts the whatever the message user sends. So now let's look into the usage of this notification service. So here the test class is just a main method where we want to really understand what it does. So notifications, we create an object for notification service, right? And then we create a notifier which is an SMS notifier here, right? So whenever you want to notify, So if you look here, the notify method accepts a notifier as well as the notification message that we want to send. So you see, we are we are passing an SMS notifier, and we are, what we want to say, whatever the notification or whatever the message we want to pass, we are passing. Let's say if you want to do it via WhatsApp notifier, then we simply need to create new WhatsApp notifier, and that's all. Let's say if you want to notify via notification WhatsApp notifier, then you just simply feed the notify method with WhatsApp notifier and also the message, right? So this way you'll be able to, without modifying the existing things, you'll be able to freely achieve greater functionality or additional functionality. You can expand. I mean, the notification concept or the notifiers have been expanded here from one email and then next SMS to WhatsApp notifier. God knows in the future what kind of different notifiers may come. So but rather than modifying the existing class, this is very good way to achieve maintainability and achieve without any modifications. I mean, it looks clumsy to keep all things together and modify the same thing day by day as and when things keep on growing, right? So yeah, this is the reason why open close principle is that important. And let's go back to the third principle, which is Liskov substitution principle. Again, we have already, I mean, let's look at the definition. So that by definition, Liskov substitution principle states that objects of a superclass should be able to replaceable with the objects of subclass. Let's say, let's go into an example and talk about it. And if S is a subtype of T, which is S is a class of child of T, then you should be able to use S instead of T. Let's say if P is a parent and C is a child, extending parent, then the reference of the P should be able to hold the object of C, which is child. So let us take a look at the example again, the compliant one versus the non-compliant. Yeah, let us go back to the bad example, the non-compliant one. Here I have a class named bird where I have defined a method called fly. So if I want to, extend something, some other bird, maybe ostrich or maybe parrot or whatever, that also flies, there is no issue. And I can simply say bird B is equals to new parrot, bird B is equal to new sparrow, whatever, because they all fly. But if I look into some other example, which is ostrich, I'm extending it from the bird, but can we really say that ostrich is a bird? Because it does not implement the fly method. It does not have the potential to fly, right? For the sake of, skipping compilation error, compilation exception, compilation error, I have just, overridden this method, but I'm not doing anything here, right? So usually ostrich does not have anything, any method inside it, or, it does not have the capability to fly, right? So this is like we cannot fit an ostrich object into the reference of the bird, right? We cannot say bird B is equal to new ostrich, right? Because it does not really implement the fly method. So whenever you do something, whenever you write something, you should you should keep that in mind. I mean, thanks to the compiler that it will force us, but are we really utilizing the capability? Let's say if I don't have, if I have a, let's say I can I can I can manage it by using, by simply declaring or by implementing the fly method by not doing anything in the method, or if it returns something, I can say some return null, something like that. But that is not a great fit, right? So these are the things that we need to avoid in case of Liskov substitution. But rather what we can do is, if you look into the good example, you can create a bird interface and you can declare a method eat, and you can declare a flying bird, and which can fly on top of eating, right? I mean, flying bird itself states that it is a bird and it has a capability to fly. And when it comes to a class parrot, I mean, when it comes to a parrot, it can implement flying bird, which means it can fly and it can eat. But when it comes to ostrich, it can only eat but it cannot fly. There could be many other things, but the subject under the test is all about the Liskov substitution, right? So this way, by doing interface segregation, we are able to freely identify freely identify each capability, and not not write unnecessary logic or not, kind of, if you look into this ostrich example, we try to, to avoid the errors, we are forced to write this, but that's not a good practice. Yeah, so here if we look into the way how Liskov substitution principle work, we are able to substitute uh, the the bird is a super one and the ostrich is a subclass. So we were able to fit a subclass object into that of a superclass, right? So the bird B usually, if it were a class, you should be able to fit in bird B is equal to new bird, but it can also accept bird be equal to new ostrich or any subsequent childs that are extending ostrich or that are extending parrot will also be fitting into the bird. So that is the beauty of the Liskov substitution principle, and you have to make sure that your class in such a way that the whatever the subclass that you are writing should inherit all the capabilities, should stick to all the capabilities, as well as it has the additional capability to go beyond the capability that is provided in the parent. So yeah, this is what is the Liskov substitution principle, and let's jump back to the next principle, which is interface segregation principle. So the interface segregation principle is, again, I mean, while we discuss the past few principles, we have already been covering this principle as well. So the moment we try to segregate the interface, like let's say in the previous example, we tried to separate the fly method and eat method, right? If it were in the uh, same interface or same class, same interface, then then the implementer is forced to implement eat and fly both at the same time. But when we did bird and when we did flying bird, we we have made sure that it is segregated, and if you want to only implement eat, you can do that. So that's how you need to the reduce the scope of the interface. You have to keep it as limited as possible. That's fine. If even if your interface is having a single method, that is totally fine. So let us look into an example. Then we can clearly understand what this principle and what are the advantages of this principle. Let us again look into the bad example. So now here I have a worker interface. I have a method called eat and work. I mean, if you do not pay close attention to to it while you write, you create whatever you think is right at that moment. But that's where the question is. That's where you have to think about the solid principles, the principles that people have decided it. I mean, people have defined it such that you do not go wrong in the future. So you have to think about it, like keeping work and eat together, or keeping adding few more methods together is a good choice or not. So that's what the question you need to think about while trying to adhere to interface segregation. So if you see, the problem here is human worker implementing worker and robotic worker is implementing worker. These guy human, we eat and we work, that's fine. But when it comes to robotic worker, it does not. I agree that when you create a worker interface, you might not have thought about robotic worker. But that's where the interface segregation principle is coming into the picture. Even if you don't know what may come in the future, you have to think in such a way that okay, I'll try to split up, I'll try to segregate as much as possible. So that's how, even if you do not imagine that okay, maybe robotic worker may come in future, then if you do not know what happened in the future, but if you adhere to the principle, then you will get the advantage of this principle. So here again, in the just like the previous example, we had to override, we had to just to avoid compilation, I have written the fly method, right? But it does not have any to this robotic worker does not have anything to do with the eat method here, which is quite wrong here. If I say like this, then it would complain about this cannot be possible, right, without implementing it. So this is the reason why interface segregation is important. Let's look at the example. So now I have a workable interface and I have an eatable interface, and I have segregated the capabilities of one interface into two now here, each containing only one responsibility or one method. So when I say worker interface, he can implement workable as well as eatable, but when it comes to robotic worker, he can only implement workable. So that's how you are trying to segregate the interface. and you are not forcing the robotic worker to implement the eat method because you have already segregated into two different interfaces, and now robotic worker is not implementing the eatable interfaces. So this is the beauty of interface segregation. So whenever you try to write any interface, any of your service class, see to it that the service or the implementation class does really have to implement all these things to achieve the functionality, or is something more that you are adding that maybe this is unnecessary for this particular class to implement, then split it up, then segregate it, move it to a different interface. That's fine. In the current situation, in the service is able to do both of them just like the human worker. That's fine, you can keep workable and readable. But at a later date, if something comes up and it does not have to implement all of them, then you can choose between eatable, workable, and if there is something else you can choose between, you can pick whatever you want by not altering the existing code base. So that's how interface segregation works. And let's talk about the last one, which is dependency inversion principle. So dependency inversion principle states that you should not depend on the concrete implementations, but rather you have to depend upon the abstractions or interfaces. So by definition, if you see here, high level modules should not depend on low level modules. Both should depend on abstractions. So let's say in all of the examples like we have already covered, but I am going to show one precise example for this one as well. So here again, abstraction should not depend on the details. Details should depend on the abstractions. In simple terms, you should not hard code anything. You should depend on the interface and let the client or let the caller party decide what kind of implementation he want to pass it. So that's how dependency inversion works. And let's take a look at the again real life Java example. Let us look at again bad example with non-compliant. Here there is a email service which is having, I mean, I have written two classes in the same things as that I can show you at a single time. Just this is a different class and this piece is a different class, and this piece is a different class. I hope you understand that. So here the class student notifier is tightly coupled with the email service, which only sends an email. But the student notifier, the class should have the capability to send or notify the student not only by email, maybe in future if they want to communicate by an SMS or an email or a WhatsApp or a different approach which might come in the future. So you should not depend on the implementation. Email service has its own implementation, but rather here you should be referring to an interface which implements which has the potential, which has the methods of email service. So if you yeah, let me show the example and then we can talk about it. Yeah, here this is tightly coupled, and in the notification, student notifier can only be notified by an email, right? But in case of a compliant solution, I have defined a notification service which has I have defined an interface, and in which I have defined a send method. I did not do the implementation here. I have various implementations: email service, SMS service, and WhatsApp service. I think we have already covered this example in the previous one, right? So these are the different services that has the capability or that implemented the capability of the notification service. Now all you need to do is tie up the student notifier with the notification service and not with the individual email service or WhatsApp service or SMS service. Let's look at how it is done. So there is a student notifier class again, and which has, instead of depending on the email service or any hard coded SMS service or any tightly coupled one, we have declared a interface here. So whenever you want to instantiate, or whenever you want to create an object of student notifier, we have mandated the constructor to accept the notification service implementation as an input. So the notification service, since it is an interface, the by Liskov substitution principle, we can pass in this parameter, we can pass any of its implementation, any of its subclasses, which can be email service, WhatsApp service, or SML service. So if you pass that, and if you send a notify student, then the send method is invoked, and the send method of the the particular service that you passed here will be invoked. Let's come to the usage. I think we are already talking about the Liskov principle also here. So that's how these principles are basically. So this is the usage. I have created the notification service. Unlike the non-complement, I have created email service. In the compliant one, I have created. Sorry, where is that? Yeah, in the notification service, and I am referring it to a email service here. So I have created student notifier object, and I have fed the service of the email to this student notifier. Whenever I invoke the notifier dot notify student, the method, I mean this method of the email service will be invoked. This method, yeah. So this is how the dependency inversion works. Like let's say at some point of time, now I want to uh, notification service. I want to send it via different notifier. Notification service. I say service 2 equal to new WhatsApp service, right? Then I'll create student notifier. I'll either create a new notifier or modify the existing one. Notifier 1 is equals to new student notifier, and that accepts service 2, which is WhatsApp notification, right? So now if I do a notifier 1 dot notify student with some, message, let's say he has got a first grade in the class, then all you need to do is invoke the notify method by using the object of student notifier, which is tied up with the notification service, again, which is implemented by WhatsApp service. You see, these things are interdependent. I mean, it could be a little bit confusing, but if you take a closer look at this does all the job, and it is in a much simpler way. If you look at the non-compliant one again, here we are tying up the the dependency email service or the notification with only email service. But here, if you look into the usage, here we have, let's say, student notifier method, student class. Here we are tying up with notification service, and at runtime we are accepting the implementation of it. So whatever implementation we pass, that will be that particular method. I mean, the implementation of the send method present inside that implementation will be invoked, and it does the job. So that's how dependency inversion works. And I have created a few, I have I have some small write-up like what single responsibility principle is, what open closed principle is, and what Liskov, and what is interface segregation, and what is dependency. But the thing is, we can, by looking at the name of the solid principles, we can try to speak up something, maybe in an interview or when someone asks us. But the real challenge comes in is when you really want to implement something, when you're really working on some project or your own project or for a company, and it should not have a remark, or it should not have, let's say, who has done this, I mean, this is not so good. I mean, to to inculcate best practices, or going forward the code should not break, or maybe um, yeah, then there comes the solid principles. So if you should not think about the solid principles, when you reach halfway through the project, or when you already begin with your project. This is the first step. As soon as you learn any programming language, this becomes the first thing that you have to look into. Then only, whenever you write something, whenever you write anything, you write it good, and it will be useful for, it will have a long lasting, it will be a long lasting software or application. So yeah, that's all about solid principles that I wanted to cover today in this particular video. I hope you liked it. Yeah, thank you.